Okay, we're going to do a sample problem from chapter 9, and we're going to we just picked number 15. And frankly, we're going to do 15 and 16, to be honest with you. Consider the following hypotheses. So we have the null hypothesis, HO, where the mu is greater than or equal to 150, and the alternative is less than 150. We can actually start this problem, and one way I always encourage students to start the problem is draw the curve. Okay, draw the curve. So here's the curve. Based on this setup, is it an upper tail test or a lower tail test? I think the trick I told you was, yep, look here, and if you go to that, that's a lower tail test. Okay? So it's a lower tail test. That's the setup I'm going to have. I'm going to have some values of x, and I'm going to have z-scores because sigma's known. My test statistic is z x bar minus mu sub 0 over sigma square root of n. That's my test statistic for any question where I know the standard deviation from the population. Here they say, I have a sample of 80. Okay, so I'm going to jump right here and say, all right, square root of 80. You can plug that right in. Results in a sample mean of 144. That's x bar, 144. I know my mu sub 0 is 150. All I need is the population standard deviation. The population standard deviation is known to be 28. Okay? So based on the data that was given to me, I don't have to calculate anything really. What do you get for a test statistic? Okay, negative 1.92 is your test statistic. Okay? If I do all the math, that's what I get. All right. Let's go over here, and it says later in the question, we're going to solve with an alpha first of 0.05. So here's 0.05. That means we have 0.95 here. What's the critical value that goes with that alpha of 0.05? Excuse me?
1.96.
Let's see. 1.645 it should be. With a 95% in the body and a 0.05 in the tail, 1.645. But of course it's going to be negative. Okay? So that's sort of the ruler against which we're going to measure our data. And frankly, if our data lands inside the hump, inside the major part of the curve, we're going to accept HO. If it lands in the tail, we're going to reject HO. Here at a negative 1.92, I'm landing here. Negative 1.92 negative. Okay? With that test statistic, I'm going to get an area, a p-value. What is that p-value? So I'm going to go to my table in the back. I'm going to find the z-score of negative 1.92, and I see the p-value is 0.0274. 0.0274. Okay? Now I'm going to run the test, basically just using the criteria that I've had before, and I write this out usually because I don't trust myself. Reject HO if z is less than negative z at alpha. Negative z at alpha is negative 1.645. Z we calculated to be negative 1.92. Is that true or false? That's true. Now we're dealing with negative numbers, so negative 1.645 is greater than negative 1.92. True. We reject HO if it's true. Reject HO. P-value approach. Reject HO if the p-value is less than alpha. Alpha in this case is 0.05. The p-value is 0.0274. Is that true or false? That's also true. Good, they have to match. We reject HO. That means we're accepting the alternative. We've statistically proven for purpose, actually we're not statistically proving, we've made the decision. The statistics, the data have told us to reject the null hypothesis and accept the alternative The mean is actually less than 150. Do your decision based on that. Sometimes they give you a fact pattern here. They didn't give you a fact pattern. Okay? How would this question change when it says that alpha is 0.01? Okay? What's going to change when alpha is 0.01? Is our test statistic going to change? Nope, you're right. Alpha changes, okay, so it's going to be a smaller area. And our critical value is going to change. What's our critical value going to change to at 0.01? 2.33, negative 2.33. And the area that corresponds with that is 0.01, and this is 0.99. What changed is the ruler, not the data. Okay? Jackie, why are you looking odd at me?
Sorry, where did you get the negative 2.32?
3.3. Basically, just from these standard tables. Okay, I have 0.01 there. I have a critical value of 2.33. I'm in the lower tail, so I'm making it negative. Okay? The test data stays the same. We still have a test statistic of 1.92 negative and the corresponding area of 0.274. But when we run this test again, we're going to accept HO because 1.92 negative is not less than negative 2.33, and the area of 0.0274 is not less than 0.01. Those are false. We reject HO if they're true. They're not true. They're false, so we accept HO, and we make a different decision. What changed? Not our data, not our calculations, the ruler against which we measured. We changed it from an alpha of 0.05 to an alpha of 0.01. We basically changed the comparison, but the data stayed the same. We moved this line from here into here, and the critical value from inside to outside our test statistic. Okay, any questions? Looks real simple now, doesn't it? Hopefully. Hopefully. We'll talk about that off the camera. We don't want anybody to. Okay. All right. I'm going to turn that off just so I can say it. Going to my mouse when I